Hello everyone, welcome back to Year 9 Mathematics. My name is Victor, and today we're going to be learning a little bit about science. So in science, we deal with extreme numbers. The distance to the sun from the earth is apparently very massive. The width of a red blood cell is microscopic, it's very small. And so writing these out with a dozen of zeros or so is very annoying, because you have to write stuff like this is only 3 zeros. These are only like 5 zeros, and I have to like write 5 more. It looks very annoying. It's not really that convenient to do that in the first place. So what we're gonna do is we're gonna be using the scientific notation. Now, what does it look like? Now I'm going to write something like this. So I have 149 600,000. Yeah, kilometers. Yeah. So this right here is the distance to the sun in kilometers. 149,600,000. Now to convert this scientific notation, we need to create a number between 1 and 10. Of course, 1 and 10. So one non-zero digit before the decimal. Okay, you want to use the habit of 1 digit before the decimal itself. This is a strict rule. We have to place a decimal point right before the very first number, which is the 1. So let's write the 1. 1.496. Now we can drop all the trailing zeros, but this number is tiny and the original number is very big. Because if you look, this is just 1,496. The above is 149 million. We have to balance it by multiplying by a power of 10. Now, let us count how many jumps it takes to get from our new decimal point to back to where it originally was at the end of the number. So let us count. So from here, 1. So 1, this is the decimal point here. 1, 2, 3, 4, 5, 6, 7, 8. So 8 jumps. It takes 8 jumps or so. Because it is 8 jumps, we multiply by 10 to the power of 8. So we multiply this 10 to the power of 8. The final answer is 1.496 times 10 to the power of 8. So positive number for big, negative number for small. So we started with a massive number, so our power is positive 8. That's an example for this. Similarly, you can do this for this as well. Positive number, this is a very big number, so we write 7.2, and then we count the jumps. 1, 2, 3, 4, 5, 6. So multiply 10 to the power of 6, just like that. That's for big numbers. That's for big numbers. What about for smaller numbers? I'll just keep the answer for the bigger number here. What about smaller numbers? So for example, something like 0.0000075 millimeters. Now we want to follow the rule, 1 non-zero digit before the decimal. So we place the decimal between the 7 and the 5. Of course, we write 7.5, and so we need to count how many jumps from a new decimal back to the original one. So we write jump backwards to the left, 1, 2, 3, 4, 5, 6 jumps or so. Yeah, to the last decimal here. So there's 6 jumps. Yeah, and because the original number was microscopic, very small, we use a negative power, so -6. So we write 7.5 times 10 to the power of -6. This ties directly into our last video, where we talked about how a negative power means by dividing by 10 6 times here. And for our other example, where we write something like 0.00045 here, we can write something as usual. With 1 digit for the decimal, we have 4.5, and then we will count it from the original one here. So 1, 2, 3, 4. So 4.5 times 10 to the power of -4. That's how you do it, guys. So today's habit, of course, always remember to ensure that there's exactly one non-zero digit before the decimal point, and do a logic check. Positive power for big numbers, negative power for microscopic, very small numbers. As you can see right here, this is the format and these are the small numbers. There you go. And these are our habits. Alright, thank you for watching the video. I'll see you next time.